Welcome to day 16. Today we're going to talk about a technique for finding integrals called iteration by substitution. This is the first technique we're going to learn for finding integrals. And let's begin with an example. Let's say that we want to find this integral. We have the integral of sine squared of x times cosine of x dx. And we're going to introduce another variable. Here our variable is x, and we're going to introduce another variable u that will equal sine of x, and the derivative of this variable u with respect to x is du dx that equals cosine of x. That's the derivative of sine of x. So here we have sine squared of x times cosine of x. So we can replace this sine squared of x by u squared and cosine of x by du dx. So we replace these two in our integral, and we get that this will equal this sine squared of x is u squared, cosine of x is du dx. So this equals u squared times du dx times dx. And now what we can do is we can cancel these two differentials dx. And you may ask, why can we do this? What are these differentials, by the way? And if you are curious about this, I've written a whole page about this. You will find a link in the day 16 guide, and if you want to learn about this, you can go to that page and read the explanation. And what we are interested in for solving integrals is that differentials behave like this, and we can cancel these differentials. So we do that, and we get that this equals the integral of u squared du. So now we're taking the integral of this function with respect to u, and this is easy to solve. We already know how to solve this. This equals u cubed over 3 plus c. This is the indefinite integral of this function. So here we get the answer with respect to, in terms of the variable u, but our original integral was with variable x. So we had to substitute back our variable x. We know that u equals sine of x, so we only need to substitute here u by sine of x. This is our integral, so this will equal sine cubed of x over 3 plus c, and this is the answer. You can check this answer by taking the derivative of this function. If you take the derivative of this, you'll get this function. So the answer is correct. You remember that you can always check your answers to your integrals by taking the derivative. Now let's talk a little bit about why does this work. What we did is we recognize an integral of this form, g prime of f of x times f prime of x. And do you recognize this? We've seen this type of function when we studied the chain rule for derivatives. And the chain rule says that when you have a composite function h of x that equals g of f of x, its derivative equals this function, g prime of f of x times f prime of x. So this function really equals h prime of x. So this means that h is a primitive of this function here, because its derivative equals the function. So what we must do to solve this integral is simply to find h, the function h. And to do that, we make the substitution u equals f of x, and our integral becomes, we substitute f of x by u, we get g prime of u times f prime of x. F prime of x is du dx, and we cancel the dx, and we get the integral of g prime of u du. and we note that this is the integral of a derivative, and the integral of g prime, that is derivative of g, is g. But this integral will be g of u, but g of u is g of f of x, thus h of x. So the trick is that this integral here is usually easier to solve than the original one. So we solve this integral in terms of the variable u, and then we substitute back. So that is what integration by substitution is all about. In the next videos, we're going to solve more examples using this technique. That's all for now. Thank you for watching, and see you next time.